In this video, we're going to review incenters of triangles and circumcenters of triangles and their properties and how we can figure out which parts of these triangles are congruent based on the incenter or the circumcenter. So we're going to start with incenter. So the incenter is where the angle bisectors meet. So angle bisectors means that the angles are getting cut in. So if you look at this picture, that means that this angle is cut in half, this angle is cut in half, and that angle is cut in half. So that's the first part. The next part of incenter. If you go from the incenter perpendicular to the sides, so you're drawing line segments from the incenter perpendicular to the side, perpendicular to the side, perpendicular to the side. Those three green line segments are going to be congruent to each other. In addition to those three segments being congruent, we're going to have three other sets. And it's the parts of the sides that meet at the corner. So what I mean by that is from where that perpendicular line hits to the corner. So those two sides are congruent to each other. Next, and the same thing's happening at each corner, at each angle. So from here to here. Is congruent. And then last corner angle from here to here is congruent. So the lines that are perpendicular to the perpendicular from the incenter to the sides are congruent. So that was the first set that we talked about in green. And then each of the sides from the angles, you have a set that is congruent. So the orange set, the red set, and this purple set. So that allows us to figure out which parts of the triangle are congruent based on having an incenter. Now we're going to review circumcenter. Circumcenter is where the perpendicular bisectors meet. So perpendicular means right angle, bisect means it's going to be cut in half. So that means we have right angles, right angles, right angles, and also the sides are cut in half. So this side is cut in half, this side is cut in half, and this side is cut in half. So if you want some color coding to kind of help you see it better, here to here is congruent, here to here is congruent, and here to here is congruent. In addition to those three sets, the distance from the circumcenter to the angles or to the vertices is congruent. So from the circumcenter to the angle, circumcenter to the angle, circumcenter to the angle. All three of those are congruent. So that gives us which line segments are congruent based on the circumcenter. And don't forget, you may need to use the Pythagorean theorem to find missing parts. Right triangle across from the right angle has to be your C, and then it doesn't matter where you put A and B. but we'll use that in some of the examples that we're going to use to review. So we're going to look at a couple examples to review circumcenter and incenter to find the missing segments in a triangle. So let's look at this first problem. This says if Z is the circumcenter, so that's important to know that we're talking about the circumcenter. Then we have to find each of these missing parts. So remember, the circumcenter is where the perpendicular bisectors meet. So perpendicular bisectors. So this side gets cut in half, this side gets cut in half, and that side gets cut in half. Also, if we look back to when we were talking about circumcenters before, the distance from the circumcenter to the angles is congruent. So circumcenter to the angle, circumcenter to the angle, circumcenter to the angle. Those are all congruent also. Alright, so first thing that we're looking for is TU. So TU is this distance. And remember, since the sides are cut in half, that means that since XU is 19, then the other part of it is 19. So the whole thing, coming from the two parts added together, will be 38. Next thing that we're looking for is VY. So VY is just this part. So if the whole thing is 34, remember it was bisected, so it was cut in half. So divided by 2, 34 divided by 2 gives us 17. So each side is 17. So VY is 17. Now we want UZ. So UZ is right there. Now here we're going to need to use the fact that from the circumcenter to the angles, they're all congruent. These were all congruent. So since this is 21, that means UZ is 21. Now we want WV. So WV is this part right here. So in this case, we're going to need to use the Pythagorean theorem. So we have a right triangle where this is 21, this is 15, and then that's what we're looking for. So remember, across from the right angle, we have to call that our C, and then it doesn't matter which ones you call A and B. A squared plus B squared equals C squared, so fill your values in. And then evaluate. Solve for x squared. And then take the square root. So once you take the square root, we should get x to equal 14.7. So WV will be 14.7. And then the last one that we're looking for is TV. So TV is that whole distance. So if this part that we just found was 14.7, then the other part is 14.7. So 14.7 plus 14.7, kind of like we did in the first part A, means that TV would be about 29.4. Now we're going to look at an example using the incenter. So remember, incenter is where the angle bisectors meet. So these angles are cut in half. And then looking back at when we first talked about incenter, the incenter, the distance from the incenter to the sides perpendicular is congruent. So that was these green segments. So we want to make sure we put that in our picture that those are congruent. So incenter, perpendicular, incenter, perpendicular, incenter, perpendicular. Those are all congruent. Alright, so now let's also remember that with your incenter, the sides connecting the angles are congruent, the parts of the sides. So those parts were congruent, these parts were congruent, and those parts were congruent. So we want to mark that off in our picture also. So here to here was congruent. Here to here is congruent. And here to here is congruent. If the colors make it easier to see, you can do that, but if you want to use the tick marks, you can use the tick marks. Sometimes it can just become a lot to have so many tick marks. Okay, so first thing we're going to look for is NP. So NP is right here. Now remember, those three green are all congruent, so we know that one of them is 8. That means that both of the other ones are 8 also. So that means NP is 8. Now we want NK. So NK is congruent to KO. So since this is 17, that means that's 17. So NK is 17. And then we want PK. So PK we have right here. And we don't have that, and it's not congruent to anything. So we're going to need to use the Pythagorean theorem here. Where this is 8, here's our right angle, this is 17, and that's what you're looking for. So label them, make sure you call your hypotenuse C across from the right angle. Doesn't matter which ones are A and B. And then we'll use our Pythagorean theorem, A squared plus B squared equals C squared. So 8 squared plus x squared equals 17 squared. And then evaluate. Actually, I have my numbers in the wrong spots. Let me flip-flop them. 17 squared equals x squared. That looks better. So we have 64 plus 289 equals x squared. 353 equals x squared. And then we got to take our square root. So once you take the square root, you should get x to be 18.8. So PK is 18.8. And then the last thing that we're looking for is LO. So LO we have right here. It is congruent to ML, but we don't have ML. So we're going to need to do Pythagorean theorem here also. So we're going to need to look at a different right triangle. So the right triangle we're looking at now would be this one that I just outlined in gray. So we're going to have 8, 13, and then that's what you're looking for. So this is our C value, A and B. Fill your values in. So 8 squared plus x squared is going to equal 13 squared. (64 plus x squared equals 169. So subtract 64 from both sides, and you get x squared to equal 105, and then take the square root. So you should get x to be 10.2. So LO is 10.2. So that's just a review of what the incenter and circumcenter are and how we can use them to find different sides or segments within a triangle.